this video, we're going to talk about different types of quadrilaterals and understanding the properties of quadrilaterals. Real quick, the definition, any four-sided polygon is a quadrilateral, and we're going to study trapezoids, parallelograms, rhombus, rectangle, square, and we're also going to talk about a kite as well. The properties of a trapezoid. A trapezoid has one and only one pair of parallel sides. Okay, those are the properties. Okay, so if we have two parallel lines here, okay, so we can use what we know about transversals and parallel lines, right? That if this is A, B, C, and D, okay, these are same side interior angles, so we know that A and C are supplementary, and B and D are also same side interior, and so B and D would be supplementary. So what that means is A plus C equals 180 degrees, and B plus D equals 180 degrees. Properties of a kite. A kite is formally called a trapezium. It's a quadrilateral with no parallel sides. It has two pairs of consecutive congruent sides. Okay, consecutive meaning one right after the other. So this side is congruent to this side, and then this side is congruent to this side right here. Opposite sides are not congruent. Okay? The diagonals are perpendicular to each other. Okay, that means they create a 90-degree angle. And notice that only one diagonal is bisected. Okay, so in this one right here, see how this one is the only one that's cut in half. Okay, this one is not cut in half. Properties of a parallelogram. Okay, opposite sides of parallelograms are parallel. Right, that's kind of the name of parallelogram. Opposite sides are congruent. Okay, so not only are they parallel, but they're also the same length. Opposite angles of a parallelogram are congruent. Okay, so this angle is congruent to this angle. This angle is congruent to this angle. Diagonals of a parallelogram bisect each other. Okay, that means that this side is equal to this side, and this side is equal to this side. Okay, it does not mean that the diagonals equal each other. Okay, we don't know that about a parallelogram. Consecutive angles of a parallelogram are supplementary. Okay, that means if we had 1, 2, 3, and 4, that means 1 plus 2 equals 180. 2 plus 3 equals 180. 3 plus 4 equals 180. And 4 plus 1 equals 180. Okay, so if you add up any two angles that are right next to each other, they'll equal 180. Okay, properties of a rhombus. A rhombus is a parallelogram, so that means it has all of the characteristics of a parallelogram that we just talked about. In addition, it also has four congruent sides. Okay, and the diagonals of a rhombus are perpendicular. Okay, that means when the diagonals go across from each other, they form a 90-degree angle. Okay, the diagonals also bisect opposite angles. That means that the diagonals cut these angles in half. Properties of a rectangle. Okay, it's a parallelogram, so just like the rhombus, it includes all the things about a parallelogram. Okay, but in addition, it has four right angles. The diagonals of a rectangle are congruent and they bisect each other. Okay, that means that this side equals this side equals this side equals this side, and they equal each other across. Okay, so this long diagonal equals this long diagonal, and this side also equals that side. Okay, properties of a square. A square is a parallelogram, a rectangle, and a rhombus. So it has all of those characteristics that we just talked about of everything. Okay, it has four congruent sides, it has four right angles. The diagonals of a square bisect each other, are congruent, and are perpendicular. And they also bisect the opposite angles. Okay, that means that they cut them in half. So since we know it's 90 degrees, we know that each one of these smaller angles is 45 degrees. Okay, here are some examples. Okay, we know that ABCDE is a parallelogram. All right, so the only properties that we can talk about are the properties of a parallelogram. Okay, so what we know about a parallelogram, right, is this side is parallel, this side are parallel. They're also congruent to each other. We know that this big angle is congruent to this big angle. This big angle is congruent to this big angle. We also know that this side equals this side, and this side equals this side. Okay, so find the measure of the given angle. So right here we want to find the measure of angle 1. Okay, now the way we find the measure of angle 1 is it's a small triangle right here, right? And we know that a triangle adds up to 180 degrees. So since we're given these other two sides, we want to add these two numbers up, 117.6 plus 23 is 140.6. Okay, so we're going to take 180 minus 140.6, and we're going to get 39.4. So we know the measure of angle 1 is 39.4 degrees. Okay, now the measure of angle 2 here, okay, if we look here, we know a parallelogram, we know that this line is parallel to this line, okay, and it's cut by this transversal right here. So if you look at 2, okay, it is on the interior, right, of the parallel lines, but it's on opposite sides of the transversal. Okay, so 2 is opposite interior angles right here. So we know that these are congruent. Okay, so we know that, excuse me, alternate interior angles is the other word for it. So the measure of angle 2 is 80.7 degrees. Okay, since this is 80.7, that's 80.7. Okay, now to find the measure of angle 3. Okay, we know the measure of angle 2 is 80.7. Okay, we don't have an opposite angle over here to tell us what angle 3 is. Okay, so what we're going to have to do first is figure out what this angle is. Okay, we know that 117.6 forms a linear pair with this angle. So all we have to do to find that angle is take 180 minus 117.6. And that's going to give us 62.4. Okay, so this angle is 62.4. So now we're going to take 62.4 and we're going to add it to 80.7, and that's going to give us 143.1. So we're going to take 180 and we're going to subtract that from 143.1, and that's going to give us 36.9. So we know the measure of angle 3 is 36.9 degrees. The measure of angle 4, okay, same thing right here. These are parallel, okay, so we have alternate interior angles right here. So we know the measure of angle 4 is 23 degrees. And then if we know the measure of angle 5, to find the measure of angle 5 right here, okay, we could do two things, right? We know that this angle right here is 36.9, so we could add these up and subtract 180, or we could just notice that we have vertical angles right here. Okay, we found earlier that this was 62.4, so we also know that that angle is now 62.4 degrees. Okay, here's a proof right here, okay? We know that AMCN, okay, so this small one right here, not the big rectangle looking one, but the smaller one inside of it is a parallelogram. And they have also given us that MD is congruent to NB. And what we're trying to prove is that this triangle, right, ABN is congruent to CDM, okay? So AMCN is a parallelogram, okay? If you look at the next reason, it says opposite sides of parallelograms are parallel, okay? So what we're going to put in our statement here is we're either going to put AM is parallel to NC, or we're going to put that AN is parallel to MC right here, okay? And to figure out which one we're going to use, Okay, we're going to look at this next problem down here. It says CMD right here, okay? CMD corresponds or is congruent to NAM, okay? So they're going to talk about these two angles right here, okay? Now corresponding angles, right, have to be on the same transversal. So these are the two parallel lines they're talking about. So we would say AN is parallel to MC. Okay, and we know that because opposite sides of a parallelogram are parallel. So the next thing they told us, right, is that CMD is congruent to NAM. Okay, from there they say that angle NAM is congruent to angle MCN. Okay, so we know that these two angles are congruent. And here I still just write one line to show congruency because since this is congruent to this and this is congruent to this, we now know all three of these are congruent to each other, right? But the reason we know that these two are congruent, okay, they don't share a transversal, so we can't use corresponding or any of that kind of stuff. But we do know that opposite angles, right, of a, sorry, just a second. We do know that opposite angles of a parallelogram are congruent. Okay, and I just use little symbols right here, right? This is angles, and that means congruence. So since I was running out of rooms, okay? Now let's look down here. It says corresponding angles are congruent. Okay, so now to figure out what they're talking about here, well, they've just told us that this angle was congruent, right? And if you proofs are following a step-by-step basis. So if we just talked about this new angle right here, we're wanting to make this angle congruent to something else with the corresponding, okay? So here we're going to say that angle MCN, and we're going to look for its corresponding angle, which is this one right here. Okay, so angle MCN corresponds, right, is congruent to angle ANB. Okay, so corresponding angles are congruent. All right, so now what we can say is that angle CMD, right, this angle right here, is congruent to this angle right here, AND. Okay, and that's easy to see because since this one was congruent to this one, and this one was congruent to this one, and this one was congruent to this one, we can now say that these two are congruent because of the transitive property, right? One to the next, to the next, to the next. Okay. Now we are, the next thing we can say is that AN, this line right here, is congruent to MC, this line right here, okay? And that's because opposite sides of a parallelogram are parallel, okay? I'll just use the symbol for parallel right there. Okay, now the next reason that gives us is the given. So we know that this one says that MD is congruent to NB. Okay, these two right here. So now we can say that these two triangles are congruent, okay? And we have to give our reason for it, right? So we're going to look at our triangle postulates, right? The angle, side, 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 those. And if we look here, we have side, right? Then we have included angles, and then another side. So this is because of side, angle, side is the reason. Okay, and rectangle, all right, this is a rectangle, TUVW. The measure of angle TXU is 110 degrees, and TV, so this whole line right here, equals 13. Okay, so we want to find the following measures, and if there's not enough information, then we'll write any I, which is not enough information. Okay, so remember, properties of a rectangle are all of the parallelogram properties except, or in addition to, okay, now we know that all four of these sides are congruent, right? They all equal each other, and we know that we have four right angles, okay? So to find Tx, okay, if we know that TV is 13, okay, then all we're going to do is we're going to take half of 13, which is 6.5. So we know Tx equals 6.5. Okay, Wx, all right, now this is where we couldn't do this with a parallelogram, but since it's a rectangle, we know that they equal each other, right, and that they're all bisected. So this side, right, so Tx would also equal Wx, so Wx is also going to equal 6.5. Okay, to find the measure of angle TXW, right, this angle right here, okay, we know that TXU forms a linear pair with TXW, right? So a linear pair are supplementary. So we know this has to equal, this plus 110 has to equal 180. So we take 180 minus 110 and we get 70 degrees. So this rectangle is 70 degrees. Okay, this is a kite, okay, PQRS. PQ, okay, is 11 centimeters. QR is 5 centimeters. QT is 4 centimeters. And RT is 3 centimeters. And the measure of angle PQR is 96 degrees. So we want to find the following measures, and if there's not enough information, then we're going to write NEI, okay? So to find TS right here, okay? In order to find TS, all right, we want to compare these two triangles right here, okay? So we know in a kite, right, that these sides equal each other, okay? We know that this side equals itself, right? And then let's see here. We also know that this angle equals that angle. So side angle side, okay, for this for these two triangles right here, okay? So because of CPCTC, we can say that QT also equals TS. Okay, so we also know that this one is 4. Oh, excuse me. I'm sorry. I'm going to go off of this. Okay, I knew I was wrong on that. Okay, we don't know for sure that these two angles equal each other. We know that this is a 90-degree angle, okay? So because we have the hypotenuse and a leg that are congruent to each other, we can use hypotenuse leg, okay, HL, to know that this side equals this side, and that this angle equals this angle, and that equals that angle, okay? So this equals 4, okay? RS is going to equal 5, right? Because that's a property of a kite, right? Consecutive sides are congruent, all right? PS, okay, is consecutive with that one, so it's going to be 11, okay? And then here we have PT. Okay, now there's no property of the kite that tells us anything about PT. The 3 doesn't really give us information, so we actually don't know anything about that, so we put NEI. Okay, for this one, the measure of angle PTQ is 90 degrees, okay, and remember that was a property of a kite because the diagonals are perpendicular bisectors of each other, okay. PTS, same thing, is also 90 degrees, okay. PSR, right, PSR, this big angle right here, okay, if we look here, right, we have side, these sides are congruent to each other. This side, these sides are congruent to each other, and this long diagonal is congruent to each other. So side, side, side makes these two triangles congruent to each other. So again, because of CPCTC, we can say that this angle is congruent to this angle. So PSR is going to also equal 96 degrees. Okay, the measure of angle PQ so this smaller angle right here, okay, we actually don't know because a kite, the diagonals are not necessarily angle bisectors of each other. We don't know that, so we can't cut it in half. We don't know what this is. So this is actually not enough information on that one. Okay, and now we're going to move over to a few more examples. Okay, this is going to go under types of quadrilaterals. Okay, so this is continuing on in your lessons, but all of the information before is the same. Okay, it's all about properties. So we're just going to move on to a few more examples after that, okay? So for this one, okay, FGHI is a parallelogram. Okay, so again, it's what we know, things that we know about a parallelogram. Okay, the lines are parallel. This is equal to this side. This side is equal to this side. This angle equals this angle. This angle equals that angle. So HFG, okay, is congruent to what? All right, so look here, HFG. So this small angle, and I'm going to clear this so we can kind of see a little better. So this small angle right here, okay, we want to know what that small angle is congruent to. Okay, now we know this is a parallelogram, right? So this line is parallel to this line. These are on this transversal. Okay, we know that this angle is going to be an alternate interior angle to this one right here. Okay, so HFG is going to be congruent to FHI, angle FHI. Okay, FG, this segment right here, is going to be congruent to IH because opposite sides are congruent. And then HE is going to be congruent to FE, okay, because we know that these are bisected, so we do know that this side equals this side. Okay, these are, this is working backwards. Okay, so this is given this information, then what do you know about the parallelogram? Okay, so if one pair of adjacent sides of a parallelogram is congruent, okay, adjacent means next to each other. So one side is congruent to the next side. Then that parallelogram, okay, for 17 has to be a rhombus or a square. Okay, because those are the only two that have adjacent sides that are equal to each other, right? All four sides are equal to each other. Okay, for number 18, in parallelogram WXYZ, angle XWZ is a right angle. Okay, so it has a right angle. So WXYZ must be a rectangle or a square, right? Because those are the only two parallelograms that have right angles. If SPQR is a parallelogram, then PQ must be congruent to what? This one helps to draw out, okay? So you have SPQR, okay? So if PQ, if this is a parallelogram, then PQ must be congruent to SR, okay? Because opposite sides of a parallelogram are congruent, okay? This one says if AC is perpendicular to BD, parallelogram ABCD must be a what? And again, this helps to draw it out. Okay, ABCD. If we're talking about if we're talking about AC, okay. Oh, oops, that's why I'm like I'm sorry. That's why it's important to write your letters in order. Okay, A, B, C, D, right? They have to go in order. So AC is perpendicular to BD. So we're talking about the diagonals. If they're perpendicular, right, that means they have 90-degree angles. Okay, then parallelogram ABCD, right? This is a parallelogram. Okay, it must be a rhombus or a square. Okay, now if you think about the other shapes that we talked about, right? We talked about a kite. A kite's diagonals are also perpendicular, but a kite is not a parallelogram. Okay, because a kite does not have any sides that are parallel. So if it's a parallelogram, it has to be a rhombus or a square if the diagonals are perpendicular to each other. All right, on this proof right here, okay, it says ABCD is a parallelogram and FCED is a rhombus. We want to prove that ABCD is a rectangle, okay? So what we're trying to prove, if you look down here at the last statement, it says if diagonals of a parallelogram are congruent, then it's a rectangle. So what we are trying to prove here is that BD is congruent to AC, okay? So the first thing if we know that it's a parallelogram, okay, then we know that AF is congruent to FC, and we know that BF is congruent to FD, because right now all we know is it's a parallelogram. Okay, so these are the things we know for sure. This side equals this side equals this side. And that's diagonals of a parallelogram bisect each other. Okay, FCED is a rhombus. That's our given. Okay, so FD is congruent to FC. Okay, and that's because of properties of a rhombus. Right, that's just one of the things that we know that's true about a rhombus. Okay, so if we know that FD is congruent to FC, right, then we can say that AF is congruent to BF is congruent to FC is congruent to FD, right? Because we've already now proven that these, right, are congruent to each other, okay, because of substitution. So now we can say that they're equal to each other. And we're talking about these little small segments, right? The little small ones. In order to prove the rectangle, we got to prove the big segment, okay? So since we proved the little small ones are congruent to each other, okay? That's the definition of congruent segments. So if AF equals BF equals FC equals FD, then we know that AC, right, this big line, is equal to AF plus FC. And we know that BD is equal to BF plus FD, okay? And that's our segment addition postulate. Okay, so now we can say that AC does equal BD. Okay, and again, we're going to that's because of substitution, right? Because if we look here, right, AC is equal to AF plus FC, right? And we know that AF equals FC, BF plus FD, BF equals AD. All of these equal each other. So therefore we can say AC equals BD because we just substituted in, okay? And then now we can say that AC is congruent to BD, and that's just definition of congruence. And because AC is congruent to BD, we know that ABCD is a rectangle because diagonals of a rectangle are congruent. And that is the end of understanding quadrilaterals.